Well, hello, everybody. Uh, my name is John Ball, Math 0308. Uh, I'm going to give you my email address and all that stuff here in a minute. It's going to seem like you're drinking from a fire hydrant. Uh, the information is going to come real fast because the class is only 8 weeks, half the time that it normally is. Now I know you all work, and I'll try not to waste any of your time. Now, much of the course content you've already seen, but it's necessary that we review. Um, I'm going to make this class as enjoyable as possible, but it is algebra. What could be more fun than that, especially at 9 in the morning? So I'll do my best. I know that most of you had demanding jobs, so I'll try not to waste your time and get you home as quickly as possible. I'll record the meetings and I'll send you a YouTube link so you can review them at your leisure. Please turn your cell phones off. Buy a scientific calculator. Um, at the very least, buy this one. If you can see it, it's a Casio. It has two lines. Let me show you. First, you turn it on. If you'll notice, if you can see it, it has two lines. At the top, it's the problem, and on the bottom, it's the answer. Do yourself a favor and pay the extra, I don't know, $2 or whatever it is to buy this one. They're only about $10, so go and get one. If you can afford it, these are $100. This is a Texas Instruments TI-83 or TI-84, or they make one even above that one. We won't be using this calculator very much in this class, but you will at some point. But if you get this one, this Texas Instruments, you won't need to get the Casio version. We're going to move through the first 5 chapters very fast. So it's imperative that you review the class every day. You've all figured out by now that math classes are like ladders. If you miss one rung, it's very frustrating to try to catch up. So if I'm talking too fast, please let me know. Now, I'm not showing anybody here as participants here, so I sure hope everything got did right. If you don't understand what I'm saying, please ask me to repeat. You're not going to hurt my feelings. I have nothing else to do but this class. I only have one class this semester. Now, at this point, you need to take a drink of your Diet Coke. Oh, that's good. If I ask you a question, please do not say I don't know. That means that you don't care and you're not willing to try. So use the procedures that we talk about. And remember, algebra and geometry and all the math classes, they're all nothing but procedure, how you do things in what steps. I'll talk you through it if necessary. I'll try not to leave you or hang you or embarrass you, but I will give you time to try to figure it out on your own. This misery is important, and the procedures and the vocabulary you learn here, you will use in every math class you take. Plus, I know it doesn't seem like it now, but math will help you make a better decision maker. I'm usually here 30 minutes before class, or I can stay as late after class to review anything you don't understand. I'm retired. I don't have anything else to do but go home and cry myself to sleep. So please let me know. I'm here for you. That's not just something that I'm saying. This is the truth. Uh, I hope everybody got the syllabus. I mailed it out. I'll show it to you here in just a second. If you didn't get it, let me know. I'll resend it. And please check your email every day. YouTube's very useful. If you get home doing your homework or something doesn't make sense, go to YouTube, and I think um, you'll find something helpful there. You'll have a quiz on most every day. They're on D2L, and there is a time frame that they have to be done. I'm recording all these meetings, and as I said, I'll post them to YouTube for you to review, and I'll send the link to you. All assignments, tests, and quizzes are on D2L. Can you believe that? I wonder what Mongoloid came up with that. D2L, desire to learn. Oof. Okay, I still don't show anybody in class. My goodness. Let's see. Okay, and I know my handwriting's horrible. If you can't read something, please let me know. We're going to talk about vocabulary. I'm sure you've all figured out by now that vocabulary is very important in every class you take. But we're going to use these. Let me see, get a shadow out of there. We're going to use these words a lot. First of all, terms are one number, like 3, 5, 2x. Okay, that looks like it's two numbers, but it's not. It's one. 3, x, y, z. Those are all terms. Now expressions are two or more numbers, or two or more terms, like 3 plus x. Okay, it's separated by a plus or a minus. That's basically how you can tell if there's a plus or a minus in there. Then they're excuse me, they are expressions. 5x minus 2y. Okay, that's an expression. If it has a plus or a minus, it separates two terms. Okay. Now, probably the most, I hate to say the most important, but the most used thing we do in math is order of operation. Now, order of operation is PEMDAS. First time I saw that, PEMDAS. That means something in Spanish. I know it doesn't mean anything in Spanish, I don't think. It's order of operation. The P is parentheses. We do that first. E is an exponent. The 5 is the exponent, or we can say x to the e, the exponent. Now, multiplication and division are like twins. Multiplication, division, which E, V, E, or whichever comes first. Or ST, from left to right. And addition, subtraction. Again, these are like twins, whichever one comes first. Now, let me back up a little bit here. If we have 3 plus 2, before I forget, do not use x for multiplication anymore. Either use the asterisk or a raised dot. And I'll show you that in a minute. 3 plus 2 times 7. Now, which would we do first? Does it make a difference what we do first? Oh, yeah. Do we have any parentheses? No. Do we have an exponent? No. Do we have multiplication division? Yes. Here we have addition, and here we have multiplication. So we're going to do this first. So we're going to have 3 plus, and 2 times 7 is 27. 14, yeah, I knew that. Okay. Now if we did it the wrong way, we do 3 plus 2 is 5. 5 times 7 is 35. So that's not correct. Now I will tell you something, but don't tell me, Professor Burkew. They're already mad enough at me as it is. These calculators will do order of operation for you. First, you turn it on. I can't tell you how many times I've taken these things and punch all the numbers, look down, forgot to turn it on. What is it? 3 plus 2 times 7. 3 plus 2 times 7 equals 17, right? Okay, like I said, these things will do order of operation for you. They're wonderful. Okay, that's basically, and like I said, this is probably the most used part of mathematics that we do, and that's order of operation. Okay? Okay. I know it's going to seem like I'm all over the place here. But like I said, we're going to have a whole lot of different things here. Okay. Hold on just a second. Okay. The next thing is absolute value. Absolute value. Now, absolute value is how far is it? FAR. How far is it from 0 on the number line? Now, we're talking about distance here. And what kind of a number is distance? Always positive. I know always is a long time. Always a positive number. Always a positive number. Because even if you're walking backwards, you're still going in a distance, a positive distance. So it's always positive. And we say absolute value is like this. Surrounded by 2 vertical lines. Okay, so if we have the absolute value of 5 is 5, right? Always positive. The absolute value of -5 is also 5, because on the number line, 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. How far is this? How far is it? 5. Positive 5. And remember, absolute value is always positive. Now, if we had subtract the absolute value of 3, now this is nothing more than order of operation. The first thing you do is, or the first thing I would do, I have to do this because I'm stupid. The absolute value is 3, right? So what this is saying is subtract 3. Now I said absolute value is always negative, right? Well, kind of. But this says subtract the absolute value of 3. So this is actually -3. The absolute value symbols are kind of acts like a parenthesis. So if we had this, if we have 6 minus the absolute value of negative, come on, boy, think, 2. Okay, what's the first thing we want to do here? If I were you, I'd get, this is the first thing to do here is this. First of all, get rid of the absolute value symbol. So we have 6 minus absolute value of negative 2 is 2. So this is 6. This is nothing more than 6 minus 2, which is 4. Right? Right. Let's do another one of those because that's kind of confusing. If we have 10 minus the absolute value of, come on, boy, think, of 7, negative 7. Okay, the first thing you want to do here is to get rid of the absolute value symbol. So we have this equals 10 minus, and the absolute value of 7 is 7. Okay, it's 10 minus 7, which is 3. And we do one more. 12 minus the absolute value of negative 10. Okay, again, first thing you do is, like I said, the absolute value symbol is treated like parenthesis. And what does order of operation tell us to do? Where is it? What's the first thing we do? Parenthesis. Whatever's in parenthesis, you do that first. So if we have, we're going to do this first. So we do 12 minus the absolute value of negative 10 is 10. 12 minus 10 is 2. Am I right or am I right? I'm right. I'm always right. Well, sometimes. All right, let's do another one. Let's see. Come on, stupid, think. 11 minus the absolute value of 15. Again, we're going to get rid of the absolute value symbol first. So we're going to end up with 11 minus, wait, let's make this one negative 15, just to make it a little more confusing. Okay, so what's the absolute value of negative 15? 15. Now 11 minus 15. This is some of the problems that seems to give everybody fits. If you're not sure of what the answer is here, think about money. You have $11, and negative 15 is you owe $15. So this is going to be negative 4. You still owe $4. If you're not sure about this, again, please don't tell Professor Burke that I'm telling you to use your calculator. Okay, what was it? 11 minus 15. Put this in your calculator. 11 minus 15. Before I forget, double check that you entered it in right. You guys have big fat fingers. You ladies have long fingernails. So double check and make sure you entered it correctly. So I do it wrong all the time. And the answer is, you can see here, negative 4. Okay? Okay. Okay. So much for absolute value. What fun is that? Now you take a drink of your Diet Coke. Mm-hmm. Oh, it's a good Diet Coke. Mm-hmm. Okay, next thing we're going to talk about are like terms. Very, very important. Now here, like means the same. Like terms. For them to be like terms, they either have to be all numbers or they have to have, they must have a VE, same variable. Now I'll explain that in a minute. A-R-I-A-B-L-E. The same variable and exponent. Okay, they have to have the same variable. Now variables are letters like A, B, C, D, X, Y, Z, whatever. They have to have the same variable and the same exponent. So if we had 3x plus 4x squared, do they have the same variables? Yes, they're both x's. However, this one has a square, so these are not like terms. So the answer here is 3x plus 4x squared. Actually, we would say largest exponent first. I'm not going to be real wild about this, about the largest exponent first, but you will run into someone later on in your math career that will. So the correct way is largest exponent first. If they have the same exponent, alphabetical order. So like terms, if we have 5 plus 2, are these like terms? Yeah, they're both numbers. That's 7. We can combine these. And what if we have 3x plus 2y? Are these like terms? No. They have to have the same exponent, the same variables. So the answer here is 3x plus 2y. Okay, now what if we have 5x plus 9x? Are these like terms? Yes, they have the same variables. And the exponents there are 1. We just don't write it because we're lazy. And that's 14x. Very, very important here. Now, what if we have 3a minus 7a? Are these like terms? Yes. This is like you have 3 apples and you're going to eat 7 apples. Well, you don't have 7. So you subtract here, take the sign of the larger. Oh, look at my hand. Look how old it looks. Ooh. Okay, so you take you subtract when the signs are different. When the signs are different, this one's positive. We just don't write it. 3a minus 7a, when the signs are different, subtract and take the sign of the larger number. The larger number here is 7, so we're going to have negative, what is that, 4? A. How come nobody showed up? Not one person. My goodness. I took a shower and everything. Okay, like terms, very, very important. Almost everything we're going to do in this class is very, very important. Now take a drink of your Diet Coke. Okay, on numbers like this, or expressions like this, remember this is an expression because it has pluses and minuses in there. I like to look because these numbers, what's the matter with me? This is not, they're not going to get any more, they're going to get a little bit longer than this, the problems that you get, but they're not going to be any more difficult typically. They just get longer. What are the like terms? Here are some B's and here are some B's. Okay, so we have 3B plus 5B or 8B's plus 7A. Now typically we would write this 7A plus 8B alphabetical order, but it doesn't really make any difference. Okay, now what if we have this? Get this if you're so smart. 7A plus 2B minus 3A plus, come on, stupid, 5B. Now, what are our like terms here? Here's 7A's here, negative 3A's here, and we have B's here and B's here. So we combine these two. These two we can combine because they are like terms. Same variables, same exponent. So we get, what is that, 4A? 4A. 7 minus 3 is 4. And then 2B and 5B, what is that, 25? No. 7? Okay. Like I said, these problems, they really don't get any more difficult. They just get longer, is all. Let me do another one of these. 3A plus 5B plus 7A minus 4B plus 6C. Now, what are our like terms here? My mouse pad's getting in the way here. Get away, mouse pad. Okay. Okay, here are the A's here and here. That's all. B's here and here. And there's not another C, so that one's just kind of hanging off the end by itself. 3A and 7A. 3 and 7 was it 10? 10A. And we do our B's. 5B minus 4B is 1B or just B. And you can put the 1 in front here. It doesn't make any difference. It really doesn't mean anything. And then plus 6C. Don't forget about that. I tell you, when I do these, I always do them twice, or as my ex-wife would say, twice, just to make sure I'm right. 3 and 7 is 10. Yep. 5 minus 4 is 1. That's right. And then plus 6C. Okay. It's time for another drink of Diet Coke. Why has no one shown up? Not one person. I scrubbed my teeth this morning and everything. My breath isn't too bad, I don't think. Okay, so what if we have this? 5x plus 2y minus 3x squared plus 10y minus 6z. I put a little line through the z's here to distinguish it from a 2 because my handwriting's so bad. Now, what are our like terms? 5x minus 3x squared, are these like terms? No, because the exponent, this has an exponent of 2. This has an exponent of 1, so these are not like terms. I'll tell you what, let's do. Let's add 2x to that. to that. Now, do we have any like terms? Yeah. Here and here. Here and here. And these two are not alike, but don't forget about them. Okay, so if we have 5x and 2x, that is 7x. 2y and 10y are 12y. Is that right? Yeah. Minus 3x squared. Okay, don't forget about that one. And don't forget about this one. Minus 6z. And again, the proper way of doing this is largest exponent first. If the exponents are the same, then alphabetical order. So we do negative 3x squared, okay, plus 7x. Remember, this is a positive number here, so we have to put the don't forget to put the plus there. Where are we? Plus 12y minus 6z. Like I said, they really don't get any more difficult. They just get longer. Take another drink of your Diet Coke. Mm-hmm. Okay, everybody okay with this? Super duper whiz bang important. Very, very, very important. Okay. You're going to see this stupid stuff forever. Okay, now we have the distributed property. T-R-I-B-U-T-I. Distributed property of multiplication. Distributed property of multiplication. Again, very, very important. If we have 3 open parentheses, 2c plus 4. Now remember, parentheses, oh, I didn't say this before. The parenthesis makes this one number. This is one number. So we have, even though there are 2 numbers inside of it, the parenthesis makes it one number. So what we're going to do is, there's no plus or minus in between here. So this means to multiply. We multiply 3 times 2c and 3 times 4. 3 times 2c is 6c. 3 times 4 is, don't forget the plus in here. Can we combine these two things? Are they like terms? No. What if we get this? Again, we're going to multiply 5 times everything in here. This is all one number. The parenthesis makes this one number. So we do 5 times 3g and 5 times negative 2. So 5 times 3g is 15g. And 5 times negative 2, we have a positive times a negative is a negative. Can we combine these two things? No, not like terms. And if you're not sure about the pluses and minuses, gives everybody fits too. Put it in your handy dandy calculator, but don't tell Professor Burke I said. Like I said, I'm in enough trouble as it is. What are we doing? 5 times negative 2. 5 times -2 is, double check to make sure you're right here, is -10. Okay. Okay. Um, -4 times, uh, come on, stupid thing, 6n minus 2. Again, distributed property of multiplication, we're going to multiply the -4 times everything inside the parenthesis. -4 times 6n is a negative times a positive is a negative 24n. A negative times a negative is a positive, what is that, 8? Let me kind of back up a little bit here. When we're multiplying or dividing, the rules are the same. If we have a positive, I'm going to use a raised dot here for multiplication, times a positive, of course, is a positive, just like 3 times 2 is 6. Now, if we have a positive times a negative, the signs are different. The answer is negative. And if we have a negative times a negative, that is a positive. If the signs are the same and you're multiplying or dividing, if you're multiplying or dividing, the signs are the same, the answer is going to be positive. If the signs are different, now of course this also means a negative times a positive. Okay, it doesn't make any difference what order they're in. That would be negative. Okay, very important. Okay, that's distributed property of multiplication. Very, very important. Now, PEMDAS is for combining like terms, evaluating. Now, if we're solving equations, do PEMDAS backwards. The first thing you get rid of is addition, subtraction. That's number 1. Number 2, you get rid of multiplication, division. And I'll show you how to get rid of them here in a minute. Number 3, exponent. And number 4, parentheses. Okay, this is when you're solving equations. Now, solving an equation is like a plus 5 equals 9. We want to know what is a. What is the value of a? Okay, in other words, we want to know what a equals what. Now, obviously it's 4, right? Okay, so what do we want to get rid of on this side of the equation? We want to get rid of the 5. Now, equations are like seesaws. Whatever you do to one side, you have to do to the other side. So what do we want to get rid of over here? We want to get rid of the 5. How do you do that? You do the opposite of whatever it says. If it says plus 5, we're going to subtract 5. And again, whatever you do to one side, you have to do to the other side of the equation. If I were you, I would do these just like I'm doing it here until you get really good with it. Okay, so what's left over here? 5 minus 5 is 0. That's gone. So the only thing that's left here is A equals 9 minus 5 is 4. Now, what you want to do here is, if A is 4, plug it back into the original equation. 4 plus 5 is 9, so we're correct. Right? Right. Okay, let's do another one. So if we have B plus 3 equals 7. Okay, the first thing we want to do is get rid of the addition subtraction. And that's what we have here. We have addition. So we want to know what B equals what. We want the B over here by itself. Or as my ex-wife used to say, by its own self. Okay, so what do we want to get rid of here? Or what do we want to move? We want to move the 3. How do we do that? Do the opposite of whatever it says. It says plus 3, we're going to subtract 3. And again, whatever you do to one side, you have to do to the other side of the equation. Okay. 3 minus 3 is 0. So the only thing that's left over there is B. 7 minus 3 is 4. Put it back into the original equation. 4 plus 3 is 7, so we are correct. Okay, C minus 2 equals 5. Okay, we have subtraction here, so how do we get rid of, and what do we want to move? We want to move this negative 2 over to the other side. How do we do that? We do the opposite of whatever it says. If it says to subtract 2, we're going to add 2. And again, whatever you do to one side, you have to do the other. So we have C equals 7. Right? Right. Plug it back into the original equation. 7 minus 2 is 5, so we are correct. Mm-hmm. They get this one if you're so smart. 5 plus E equals 9. Okay, we want the E over here by itself, by its own self. So what do we want to get rid of here? The 5. This is a positive 5. So how do we move it? Do the opposite of what, remember this is plus, we just don't write it. So we subtract 5 from this side. Whatever you do to one side, you have to do to the other side. And we have E equals 4. Plug it back in. 5 plus 4 is 9, so we're correct. Okay. What about this? Negative 8 plus G is 2. Now, what do we want to get rid of? What do we want to move here? We want to move the negative 8. We want G over here by itself. So we're going to do the opposite of whatever it says. Plus 8. Plus 8. G equals 10. Plug it back in. Negative 8 plus 10, or 10 minus 8, is 2. So we are correct. Okay. What could be more fun? All right. Get this one if you're so smart. You have GH. Okay, what do we want to move here? We want to move the 3 to the other side. We want H over here by itself. So what are we going to do here? We're going to move, it says plus 3, so we're going to subtract 3. You just make an arithmetic problem out of this. So what's left over here? 3 minus 3 is 0, so we have H equals, now the signs are the same. We're not multiplying or dividing, we're combining terms. We're combining like terms. -7 and -3 is -10. Now you can think about this like money. Negative numbers are like owing money. You owe one person $7. You owe somebody else $3. And when the signs are the same, you add and keep the same sign. When the signs are different, you subtract and take the sign of the larger number. Mm-hmm. Now, what if we have this? 2a, there's not a plus or a minus in here. So what does this mean? This means to multiply. Now, how do we undo or how do we move multiplication? We do the opposite of whatever it says. If it says to multiply, what are we going to do? We're going to divide. Divide by 2, divide by 2. 2 divided by 2 is 1, 1a or just a equals 10. The fraction bar here means divided by. If you're not sure, put it in your calculator. 10, the fraction bar means divided by. Put it in the calculator from top to bottom. 10 divided by 2 is 5. Now plug it back in. 2 times 5 is 10, so we are correct. Uh, 3k equals 21. Again, this means 3 times k. Why is my... That's any better. This means 3 times k multiplied by. How do we undo multiplication, or how do we get rid of multiplication? Division. Divide by 3, divide by 3. 3 divided by 3 is 1, 1k, or just k, and that's what we want. K equals 7. Plug it back in. 3 times 7 is 21, so we are correct. Everybody okay with this? Very, very important. Super duper whiz bang important. Okay. L. 6L equals negative 21. Again, we have multiplication here, and we have a negative number over here. So we're going to divide everything by 6. 6 divided by 6 is 1L, or just L. Now, we have a negative divided by a positive, so it's going to be negative. Oh, stupid boy. Make that 24. I'm sorry. I'll do better. No, I'm not going to do any better. What is that, 4? Negative 4. And remember, a positive times or divided by a positive is a positive. A negative times a positive is a negative. Okay, so we have a negative divided by a positive, so our answer here is negative. And again, negative times a negative is a positive. Or if you're not sure, put it in the calculator. But don't tell anybody I said that. I'm in enough trouble as it is. Okay. Okay. Now, what if we have, these are two-step. Linear, it just means a line. Linear equations. Two-step linear equations. What does that mean? If we have 5m plus 2 equals 17. What is this? An expression. Okay, what are we going to get rid of first? Remember, we want to get rid of, the first thing we want to get rid of is addition, subtraction. Then multiplication, division. Then the exponent. Then the parenthesis. Okay, remember, we do PEMDAS backwards when we're solving equations. Okay, so what's the first thing we do? Do we have any addition, subtraction? Yes, but we do this first. Subtract 2, subtract 2. We have 5m equals 15. Okay, now we have 5m, 5 times m. How do we undo multiplication? Division. We divide everything by 5. 5 divided by 5 is 1m, or just m, equals 15 divided by 5 is 3. Now to double check this, we put the 5 back in. Now we do PEMDAS the correct way. First we do multiplication division. So it's 25. 5 times 5 is 25 plus 2. That was stupid. Not 5, you bonehead. 3. 5 times 3 is 15 plus 2 is 17. So we're correct. Okay. Okay, what if we have this? 6b minus 2 equals 30. Come on, boy, think. 28, I think. Okay. Now, what's the first thing we want to get rid of here? Addition, subtraction. How do we do that? Add 2, add 2. Now, treat this like an arithmetic problem. What's left over here? 6b. Negative 2 plus 2 is 0. It's gone. It's eliminated. Equals 28 plus 2 is 30. Now we have 6 times b. How do we undo multiplication? Division. Divide everything by 6. b equals 5. Plug it back in. Now we do PEMDAS the right way. We do multiplication first. 30 minus 2 is 28, so we are correct. Okay, we'll pick up here next time. Since nobody came, I'm assuming that there is a problem of some kind. Y'all take care. Bye-bye. Bye, bonds. Have a good weekend. Que tengas un buen fin de semana. I don't know what that means, but it sounded Spanish. Bye-bye.